Okay, second period geometry class. Luciana and I are here today to talk to you about the law of sines and cosines. Now, the law of sines and cosines are really powerful. These are two really powerful tools that will help me solve for missing sides or angles in any triangle. Okay, this can work for not just right triangles, but in any triangle. So this is going to be nice, right? So how will I do that? Well, the first thing is I'll use the law of sines. You have to have the minimum of 3 numbers given in the triangle. You have to know 3 numbers in the triangle, all right? We'll talk about, okay, so what 3 numbers? Well, the 3 numbers could be, you could be given an angle, another angle, and a side in the triangle. You could be given an angle, a side, or an angle in the triangle. Or you could actually be given an angle, a side, and a side in the triangle, all right? Now notice this last one. I know we said that for proving triangles congruent, you can't have that. But for finding missing pieces in a single triangle, you could be given this information. So don't confuse that idea. This actually, no, this one though, this last option, this will only occur. You won't do that in geometry honors. You will do this in algebra 2. This will be an algebra 2 and trig concept that you'll discuss. Okay? So let's look at these first 2 ideas and how we can use the law of sines to solve for missing sides and angles in any triangle. Well, here's what the formula says. The law of sines formula says if you take the sine of angle A and divide that by his opposite side, little a, well, that has to equal the sine of angle B divided by his opposite side, little b, which has to equal the sine of angle C divided by his opposite side, little c. So this formula is the law of sines. Now, inside of this single formula, there are actually 3 different equations we could write. We could say that the sine of angle A over little a equals the sine of angle B over little b. We could say that the sine of angle A over little a is equal to the sine of angle C over little c. Or I could say the sine of angle B over little b is equal to the sine of angle C over little c. So this one formula is actually 3 different equations. Now if you think about this, whenever you look at this equation, say this first purple equation, I have 1, 2, 3, 4 different variables in this problem. I have 2 angles and 2 sides. Well again, for me to be able to find a missing variable, I have to be able to fill in for the other 3 variables. So, for example, I might have to know this angle A, this side B, A, and this angle B, right? I could also say, maybe instead of that, and that's no good, maybe instead of that I would know this side B, this angle B, and say this side A, and I could find this angle A, right? And so on, right? Ultimately, again, for you to solve for the missing side or angle using the law of sines, I have to know 3 out of the 4 variables in the equation. Now let's take a look at how we can use the law of sines to actually do a math problem. Look at this problem here, right here. It says, solve a triangle where you know that angle A is 21 degrees, side C is a length of 12, and angle B is 43. Well, again, so let's take a look at this. I'm just going to draw some triangle, and again, it doesn't have to be drawn to scale. I'm going to call this angle A, angle B, and angle C. Well, I'm told that angle A is 21 degrees, and I know that angle B is 43 degrees. Well, to solve the triangle, that means find everything that's missing about the triangle. So I know that every triangle has 3 angles and has 3 sides. We were told that angle A is 21 degrees and angle B is 43 degrees, and that side C is 12. Right? So what do I still need to find? I still need to find angle C, side A, and side B. All right? So let's take a look at how we can do this. Well, again, we know that even before this chapter, to find this third angle C here, couldn't I just add these 2 angles together, A and B, and subtract from 180? So let's see here, 21 plus 43 is 64 degrees, and 180 minus 64, that'll give me angle C. So when you do that, you get angle C is 116 degrees. So I've got 116 degrees, all right? figure this stuff out, put them into your picture. All right? So I know this angle is 116 degrees. All right? Now, ladies and gentlemen, as you can tell, this isn't the right triangle. All right? No angles are right angles. In fact, this is an obtuse triangle. But this law of sines, again, this is the handy tool. I can use the law of sines for non-right triangles. Now, here's how you always want to do this. Whenever you want to use the law of sines, you have to see what I call a complete package. You have to see an angle and its opposite side. Well, if you take a look at this, I know angle A, but do I know his opposite side, little a? No. Do I know angle B, but do I know his opposite side, little b? No. I know angle A or angle C. Do I know his opposite side, little c? Yeah. Right here's the complete package of an angle and its opposite side. I know that I can use him to solve for all the other missing pieces. In other words, I can find little side A and little side B using the complete angle and side of 116 and 12. So to do this, here's what I'm going to do. I'm going to write the equation. Well, let's see. I can say the sine of angle C, which is the sine of 116 degrees, over his opposite side, 12. That has to equal, let's start with A, the sine of 21 degrees divided by his opposite side, little a. Right? Now again, by setting up this proportion, notice I only have this last letter, little a, left, right? Now to solve for that side, don't we first cross multiply to get rid of fractions? So I get a times the sine of 116 degrees is equal to 12 times the sine of 21 degrees, okay? Now that I don't have any fractions, notice I just have a times the sine of 116. To get a alone, wouldn't you have to divide by this sine of 116? Right? So if I divide both sides by the sine of 116, and again, don't forget that's just some decimal value, I would get a alone. So a equals 12 times the sine of 21 degrees over the sine of 116 degrees. And that's the value of a in your calculator ready for. Let's go ahead and type that in on the calculator now. Let me pull up the calculator. All right. So to do this, I've got, let's see here. Let's go alpha, y equals, and enter. This gives me a nice fraction that I can type. I'm going to go 12 times the sine of 21. Close the parentheses off to finish off that angle. Let's go to the bottom now, and I want to type in the sine of 116. Right? So this answer, this value will be the length of side A. Okay, so that's 4.785. So this little side A is 4.785. Okay? So 4.785. That's side A. Now I'm going to do the same thing, but this time I'm finding side B. All right, so I've got to use the law of sines to write another equation. That equation would say, let's see, again, I want to use the complete package of the 116 degree angle and his opposite side 12. But this time that'll equal the sine of angle B, which is 43 degrees, over opposite side B. Again, cross multiplying, I get B times the sine of 116 degrees is equal to 12 times the sine of 43 degrees. To get B alone, I divide both sides by the sine of 116. And I get B equaling 12 times the sine of 43 degrees over the sine of 116. There's your calculator ready answer. Typing that in on the calculator, I get alpha, y equals, enter, there's my fraction, 12 times the sine of 43 degrees, close parentheses, over the sine of 116 degrees, close parentheses, and I get the value 9.1, what would that be, 9.106? So B equals 1.906. That's okay, so, I wrote it down wrong. That's 9.1, not 1.9, geez. 9.106, sorry. 9.106, all right? And now I've found all missing parts. I've found this angle C and these two missing sides using the law of sines. Let's do it one more time. Ready? Let's look at this example. I'm told for a triangle that I'm given angle C's value to be 102.3, angle B is 28.7 degrees, and side B is 27.4 feet. All right? So, again, let's draw a little triangle out here. All right? Here's A, here's B, and here's C. And again, it doesn't matter how you draw your triangle. You just have to make sure and fill in the numbers the right way. So angle C is 102.3 degrees. Side B is 28.7 degrees. And side little b is 27.4 feet. Okay? So, let's see now. I've got three angles, three sides. Filling in what I'm given. I'm given that C was 102.3, angle B is 28.7 degrees, and then side B was 27.4. So now, let's go ahead and find the missing parts. Well, I can easily find angle A. Again, I can just subtract angles B and C from 180. Well, when you add that, you get what's that? 131. B and C is 131 degrees exactly. So angle A would equal 180 minus 131 degrees. So when you do that, you get 49 degrees. So angle A is 49 degrees. And we're going to fill that into my picture. All right? Now, moving on to the law of sines portion, to find little c and little b, I'm going to say, well, what fraction is complete? Where do I have the complete package of an angle on the opposite side? Yeah, I know angle B and his opposite side, little b. So I can say that the sine of 28.7 over his opposite side, 27.4, is equal to, let's start with, oh my gosh, this is a mistake. I can find a little a, my bad, little a. I can say that this, you solving for a, I can say the sine of 49 over his opposite side of little a. Again, when you cross multiply and everything, you should get in calculator ready form that that side A would equal 27.4 times the sine of 49 over the sine of 28.7 degrees. Okay? You guys, if you want to check that out, you can find the answer for that. When you're setting up the equation for B, or not for B, for little side C, you would get the sine of 28.7 degrees over his opposite side, 27.4, is equal to the sine of 102.3 divided by his opposite side C. And again, getting C alone, you would get the value of C is equal to 27.4 times the sine of 102.3 over the sine of 28.7 degrees. Okay? And again, you would just type it on your calculator, and that would find C. Now again, so to use the law of sines, you have to have a complete package of an angle on its opposite side, right? If you don't have that, then you can't use the law of sines. Well, there's another tool called the law of cosines. The law of cosines is, again, a nice tool that we can use for any triangle, not just right triangles. And again, it helps me find missing sides or angles. Now, what information, what three numbers would you have to be given to use the law of cosines? You'd have to be given all three sides, so these three sides, A, B, and C. Or you'd have to be given two sides and the angle that's included. So I could be given side A and side C and angle B. If I was given those three pieces of information, I could use the law of cosines. Now, there are three different equations for the law of cosines. By the way, and these equations are much more complicated looking than the law of sines. So I always use the law of sines first, if it's possible, because it's easier. The only time I use the law of cosines is when I can't use the law of sines. So here's the three equations. I get the law of cosine says side A squared is equal to side B squared plus side C squared minus 2 times side C and side B again times the cosine of angle A. So again, I know that if I'm looking for side A, I have to use his opposite angle A in this equation. So for you to find this missing side, A, what do you have to know? I better be given the other 2 sides of the triangle and the side opposite him. Okay? If I was looking for side B, I would have to be given side A, side C, and the angle opposite side B. In other words, angle B. And the same thing could be said for side C. Let's take a look at how I can use this. In this example, I'm given angle A is 63 degrees, side C is 12, and side B is 13. Drawing my picture out, I get A, B, and C. A is 63 degrees. Side C is 12, and side B is 13. Again, as you can see, if I try to use the law of sines, do I ever have an angle on the opposite side? Well, I'm given angle A. Do I know his opposite side, little a? I don't. So I can't use that as my complete package. I'm also given side C, but I don't know his angle C, so I can't use it there, and same thing goes for angle B. So at this point, would you agree that the law of sines is not possible here? So this is where I'm going to use the law of cosines. Well, again, if you're given a side, an angle, and a side, the first thing you need to find is the side opposite the angle that's given. I need to find little a. So I know that a squared equals b squared plus c squared minus 2 times c times b times the cosine of angle A. Filling in my numbers, I get a squared equals, well, little b is 13, little c is 12, and just filling in those numbers one more time, I get 2 times 12 times 13 times the cosine. Well, an angle A is given to be 63 degrees. Everybody see this? Well, if you notice, this whole right side is just an order of operations problem. On your graphing calculators, you can just type exactly what you see here. If I wanted to do this problem, I'm going to type in 13 squared. This is your squared button. Everybody see that? Plus 12 squared minus 2 times 12 times 13 times the cosine of 63 degrees. Now what you get when you do all this is this number 171.355. So a squared equals, what is it, 171.355? Yeah. So 171.355 rounded to 3 decimal places. Now that's the value of a squared. If I wanted to find a, wouldn't you have to square root both sides? By doing that, you get a equals, now here's a does on the calculator, to square root a number, you go second, x squared is the square root button. That's how you get the square button. And then I just want to, watch this, I want to paste this answer into there. So I'm going to hit second, and this negative sign above that, that's how you put the answer that you just got into the square root. Now hit enter, and you get a equals 13.090. 13.090. Okay, I'm that way. I should have made my list over here. I apologize. So let's see here. What have I just found? I was given A, B, and C. Angles A, B, and C. Little a, little b, little c. I was told that A was 63 degrees. Little c was 12, and little b was 13. What did I just find? I just found side A to be 13.090. All right. So putting 13.090 in there. Now I still have to find angles B and angle C. Yeah? Now, to find these two angles, it's important that you do this. Ladies and gentlemen, to find the two missing angles, this is the order in which you must find them. You always find your angles from smallest to largest. You must do your angles from smallest to largest. Okay? So, if I have to find angle B and angle C still, well, which is going to be bigger? Angle B or angle C? Or actually, which is going to be smaller? Well, since 12 is smaller than 13, doesn't that mean his opposite angle C is going to be smaller than the angle B? So I have to find angle C first. Okay? Well, wait a minute. By finding this missing side A, don't I have the complete package now? Can't I use the law of sines at this point? So couldn't I now say that the sine of 63 degrees over his opposite side 13.090 is equal to the sine of angle C divided by his opposite side 12. Now, to get C alone, this angle C, well, first of all, I know I have to get rid of the 12 and I have to get rid of the sine. The first number we want to get rid of is the 12, so I'm going to multiply both sides by 12. So I get 12 times the sine of 63 degrees over 13.090 equals the sine of C. Now, to get C alone, don't you have to move the sine over to this side? So, didn't I get C equals? Well, remember, when you move the sine across, you're going to have the sine inverse of 12 times the sine of 63 degrees over 13.090. Right? Well, doing this on your calculator, let's take a look. I'm going to get the sine inverse. So again, second sine gives me the sine inverse. It opens up my parentheses, so now I'm going to put a fraction. To get the fraction, you hit the green alpha button, the y equals button, and then enter. Now you type in 12 times the sine of 63 degrees, close parentheses, divided by 13.090. And then I'm going to come over here. You have to take the cursor to the right, close off my parentheses, and then hit enter. I get, okay, so angle C is 54.767 degrees. 54.767. Okay. So this angle C is 54.767 degrees. Well, now the only thing left to find is angle B. But wait a minute. Now we can just simply, since I know angle A and angle C, couldn't I just add those together and subtract 180? So let's see here. When you do that, you get 117.767. So angle B has to equal just 180 degrees minus 117.767 degrees. So you get angle B equals, when you do this math, 62.233 degrees. And so that's 62.233 degrees. Okay? And I think we're going to stop right there. Yeah, that's enough learning for the day. All right, guys, we'll talk more on Wednesday.